Okay, we are going to continue a couple videos before. I'm going to quickly refresh what we were talking about. We have a function f of t equals t. It is periodic from negative pi to pi. It has a period of 2 pi, so it repeats itself after this and then repeats itself over and over again. The Fourier series for this thing, I'm just telling you up front, this is the answer to the question that we are working on right now, is this thing right here. It would go on forever. The general form of that is right here. Where is it? I didn't write the general form of it here, but hold on. It is sigma from n equals 1 to infinity of 2 sine of nt. All of these have a 2 sine of nt. When the number inside of the sign increases by an integer, so does the number in the bottom of the fraction. And then they alternate positive and negatives, which gives me this. So in general, a Fourier series, when it only has sign components, which this is one like that, is the sigma from n equals 1 to infinity of bn sine of nt. So the bn in this case is highlighted here, 2 over n times negative 1 to the n plus 1. And so how do we figure it out? Well, there's this formula. I'm not telling you where this comes from yet. We'll work on it later. I just want you to see how it gets used. We take 1 over pi integral from negative pi to pi of f of t times sine of nt dt. Well, in this case, f of t is t. That's because that's this function right here. If we had t squared, it would be like that. So when I calculate that, I do some integration by parts. I have some pieces that go to 0, and then I get left with these guys. I kind of simplify algebraically a little bit, and I'm down to this spot right here. So from here, I'm going to use the property that cosine of a and the cosine of negative a are the same thing. You may say what? Well, what I mean is if I come to here and go up and I go back the same amount and go up, if I had drawn this very well, you would see, oh, these guys are the same height. Or if I were to go forward to here and down, and I go back the same amount and down, those guys have the same height. It's an even function. So what does that mean? That means that this piece right here is the same as cosine of pi n, that this goes away because it is a even function. So notice we get equals negative 1 over n, open bracket. There are 2 cosine of pi n, boom, like that. And at this point, I'm just going to write it as equal to negative 2 over n times cosine of pi n. Come on. Okay, so let me go up top. Remember, we want to get this thing right here. So let me pause. What I'm working on is finding the BN. The BN is this highlighted piece right here. So I'll do it in this color. My BN should be 2 over n times negative 1 to the n plus 1. That is just the green highlighted pieces here, times that sine of nt, because remember, I was doing my work to find the BN. Come down here. We got to get this to be that. So it's really just a matter of the unit circle again. And let's go cosine of 1t, cosine of 2, or sorry, not t, 1 pi, cosine of 2 pi, cosine of 3 pi, cosine of 4 pi. And we would do more if we were trying to work more, but I'm just going to see if we can see the pattern with that. Notice this is this guy with n equal 1, comma 2, comma 3, comma 4. So what's cosine of pi? Well, we're here, and because that's pi, this is 2 pi, this is 3 pi, and this would be 4 pi. You should see that I'm taking the x-coordinate on each of these spots, so it's going to go negative 1 for this one. Negative 1. Come around here. What's the x-coordinate? It's positive 1. Oops. Let's go like that. And then what's the x-coordinate at 3 pi? It's negative 1. What's the x-coordinate at 4 pi? Well, that's 1. What I want you to see is that cosine of pi n is equal to negative 1 to the n. Is that correct? Yep. If n equals 1, comma, 2, comma, 3, comma, 4, comma, etc. If n is the integers, right? Or if n is the natural numbers, the counting numbers, right? Because look, this would go to that first power, and actually, yeah, this is correct. Because I got cosine of pi, it's a value of 1. If I plug in a 1 here, I would get negative 1 to the 1, and it would still be negative. So, and then these even ones would get, the negatives will all cancel out. So what do I get? I get negative 2 over n times negative 1 to the n. And then my last step is to get this guy right here, and this is a negative. If I were to move it in here, I would have one more negative. So it's the same as writing 2 over n times negative n to the n plus, or negative 1 to the n plus 1. So that's how we get to this f of t equals, or the bn equals this guy, which then gives me this series right here. So here's what I'm going to say from this point out. If you are totally confused, you're like, what? That's okay. That's what happens when we do the Fourier series. And I think that with a little bit of practice and lots of playing with Desmos and just seeing this happen, that one, all the math that I did down here will become easy. I think that, the work from this down to what I have down below is going to wind up being really easy for you. And then you will also see the connection between that and this graph right here. It just takes time and practice and familiarity. And I want to at least start with this example here. So again, if you're confused, that's okay. We'll work this out when we see each other in class coming up soon. Yeah. So good job. Thank you. I'm looking forward to doing more of this Fourier series because Fourier is sick and you're going to love it.